Welcome everybody. We're going to do an experiment on pi, percentage error, and accuracy. And the guiding question about this experiment is, how does the circle size we measure affect the accuracy of our measurement of pi? Pi is a very famous ratio. It's the measurement of a circumference to its diameter. The circumference is simply the perimeter of a circle, and the diameter is its width. So, the materials are fairly simple. You need some string, you need a ruler, and some circles. How do you measure a circle's circumference? Well, it's kind of like your waist. Take the string, wrap it around, and where it starts to overlap, right there, mark it. And then unwind the string and measure the lines. So this circumference I'm measuring to be 21 centimeters. The diameter is a little bit more simple. All you do is, forget the English system, always centimeters please, measure the width of the circle. So for this circle I measured the diameter to be 6.6 centimeters. And the ratio is 21 to 6.6, or 3.18181818. So how'd I do? Well, 3.14159 is an approximation of pi, so how wrong is 3.18? How close is it to the accepted value? Well, that's called accuracy, and one way to measure accuracy is called percentage error. So it's a simple calculation. All you do is take the experimental value, subtract the actual value, and then divide by the actual, or the accepted value. So I just calculated 3.18 to be my version of pi. This is the correct pi, and then you divide by the correct pi. And the ratio, that is the difference divided by the correct pi, is 0.0128, or 1.3% error. So what you're going to do is try that trick, that is circumference divided by diameter for small circles, medium, dinner plates are good, bicycle wheels are good. Go from little to big circles. And you should predict how the percentage error is going to change as your circle size grows. As we do in every experiment, we're going to organize our measurements and calculated values into a table. Think of a good title. Think of what variable should be these column headings. Are units appropriate? Then think of what graph is going to show the relationship between circle size and accuracy. What title is appropriate? What's the independent variable? That is, what are we changing? What's under our control? What's the responding variable or the dependent variable? And then after you perform the experiment, draw your table, draw your graphs. The graph and table will tell you a story. Comment on that story. Was your hypothesis or prediction supported or rejected? And finally, how could you improve the accuracy of your measurement of pi? How could you get closer to 3.14159? Happy experimenting, and I'll see you at the next inquiry.